The last case that we have in terms of this ambiguous case with acute angles is when I've got one triangle. And we got two situations here where we can get one triangle. The first occurs when the opposite side is exactly the same as the h value. And in other words, you're going to get a right triangle. That was the example I gave you originally back over here when I created this triangle where I got the height as being 5.448. If I were to have given you angle A is 27 degrees, side B is 12, side A is 5.448, you'd see it's exactly the same height, which would then give me a right triangle. The second situation is if H is long enough in order to create a right triangle, or excuse me, create a triangle, but then the opposite side is longer than the adjacent side. When the opposite side was smaller than the adjacent side, we could fit two triangles within the triangle. But if the opposite side is longer than the adjacent side, I can only go in the outward direction. So this last one's going to have one triangle, but let's look at how we come up with that. Angle B is 50 degrees, side B is 9, and side A is 4. Just like I've done on all the others, I have to check my H value as I start off. So the first thing that I want to know here, since I'm given angle B, I'm looking at side B. Is side B long enough to complete the triangle? And when you see side A there as being that much smaller than side B, you think it's going to be, but let's just confirm our H value. So H is going to be A times the sine of 50 degrees. So 4 times the sine of 50. So my H value is 3.064. So you can see right there, my B is more than enough to complete this. But since it's not equal to my H value, I'm not going to have a right triangle. I'm just going to have a triangle that looks like this. Here's my 50 degrees. Here's my A is equal to 4. Here's side B. Here's my long side. B equals 9 over there. So given this acute situation, I'm only going to have one triangle that we can use in order to solve this. So let's solve out this triangle then. I need to find side A. So sine of A over A equals sine of B over B. Actually, I need to find angle A. So the sine of A over 4 is equal to the sine of 50, not 90, over 9. So 4 times the sine of 50, and then we'll divide that by 9. And I will get that the sine of A is 0.340464. We'll take our sine inverse, and I will get that angle A is going to be 19.905 degrees. Angle C then is 180 minus angle A minus angle B. So 180 minus 50 minus 19.905. Angle C is going to be 110.095 degrees. And then finally, I need to find side C, which, since this is going to be across from the obtuse angle, this should be the longest side. So sine of B over B is equal to the sine of C over C. So the sine of 50 over 9 is equal to the sine of 110.095 over C, which is what I'm looking for. So sine of 110.095 times 9. We'll divide that by the sine of 50. And we get C is equal to 11.033. So now I've solved that triangle since I found all the sides and all the angles. Now the last thing is just finding out, will I have 0, 1, or 2 solutions? These are all acute angles and given two sides, all an angle side side or side side angle situation. So let's see what we come up with. Here what I'm looking at for this guy, A is equal to 17, side A is 6.432, side C is equal to 22. I want to know, is it 0, 1, or 2 solutions? So what I'm looking for here is I am finding my H. So for this one, H is going to be C times the sine of A. Because I'm looking here, I'm given angle A. This is the guy I'm going to be comparing. So I'm going to put C in. So 22 times the sine of 17. And if we do that, we get the H is 6.432. If I look at that, 6.432 to 6.432, they're equal. So I'm going to have one solution. In the second one, I'm given angle A. Here is the side that I'm comparing for my height, the side that's directly across from it. So H is going to be B times the sine of A. So 29.724 times the sine of 21.6. So 29.724 times the sine of 21.6. And if I work that out, I get H is equal to 10.942. Remember, this is the height that we need in order to complete the triangle. I'm only given 10.7. I need 10.942. So this one is going to have no solution. We can create 0 triangles. The third situation, here is my angle that I'm given, and I'm going to be comparing it to side of A. So H is going to be C times the sine of A. So 18 times the sine of 32, which means my H is 9.539. I look at this, my A is more than enough to complete a triangle, so I know I've got either 1 or 2. I then look at my other side here and I see side C is 18. 15 is less than 18, which means I can fit 2 triangles within a triangle. So that one is going to be 2. This is where my adjacent side is less than that opposite side, so I can fit 2 triangles in. My fourth situation here, I've got angle C, and I'm going to be comparing it to side C. So H is equal to A times the sine of C. Once again, I'm using the side that I'm not comparing to. So H is equal to 42 times the sine of 39. And if I do that, my height is going to be 26.432. If I look at that, I can say, you know what? It's either going to be 1 or 2 based off of how I look at it. This one actually, when I don't round, is actually 26.431. So since this is less than that C value, I actually have no solutions, because this is the height that I need for the triangle, and that's what I'm given. So actually, I take that back. I do have enough. I'm going to have 2 triangles. Yeah, this is the height that I absolutely need, 26.4314562. If I look at my calculator, I'm given 26.432, so that's 2. If it were to round to 3 decimal place, I could then argue that there's 1 solution. Number 5 here, I've got angle A, so I'm comparing it to side A. So my height is going to be C times the sine of A. So we've got 18 times the sine of 50. 18 times the sine of 50. The h is about 13.789. Do I have enough in order to complete the triangle? And the answer is yes. This height, or excuse me, this side is shorter than side C, so I'm going to have 2 triangles once again. And then finally, my last one, I'm given angle B, so I'm comparing side B. So h is going to be C times the sine of 50. 32 times the sine of 50. And this height is 24.513. That's the minimum height I need for my triangle. I'm comparing it to 17. Don't have enough height there in order to complete my triangle. So I've got 0 triangles.